are followed in hashing. Okay. So this is a technique similar to your, it will have an index. It will be in a table shape, and you can insert as well as you can retrieve the elements in a faster way. That is in 0 of 1. Your normal time will be in O of 1 itself. Sorry, in O of 1 itself, you can take out the elements or insert the elements. So in that way, it is actually an easier technique. Why we are telling it is in almost constant time normally. So why we are telling that insertion and retrieving is easy is, it will be in a table shape. It is called as a hash table is maintained in this technique. So how this is processed is just like your array. You will be in array. You will be having some index values, and then you'll be having values. Then followed by each value will be stored in an index. So here it is a bit different type. It is a data structure which stores the data in a associative manner. So in other way, I can tell you it will be stored in the array format only, where each element will have its own unique index value. So unique index value will be there, and accessing that, since it has index, the accessing of the data becomes very fast if we know the index of the particular data. So and in another way, it will be acting as a storage medium also. And here there are two types which we are going to use: is implementation of hash table. Then to insert into the hash table, we maintain a that is, one is key and another one is hash function. Okay, this three part are very important here. In that particular table, you will be inserting the key. Key means the elements which are going to insert into the table, and how you are inserting it is by means of a hash function. Okay, so now this is the representation of the particular table. So this will be the hash table, and if they give the table size, based upon the table size, you have to maintain this index. Then using using that particular hash function, you are going to insert the key. Key means that elements. So this is actually very easiest one compared to your previous problems. Only that particular function alone you have to keep it in mind. Rest you can insert the particular key very easily. So it transforms. Normally the table will be from 0 to m minus 1. So this is the representation. M minus 1 is the size of the table. As m is the size, m minus 1 should be your index. And hash function, normally what is the use of the hash function is, it will transform the particular key into the table address. So when you are transforming also, you need to know about a very important term called as collision. What is meant by collision is, different keys may map into the same location. So based on the function which is provided here, when you find out the address of the index value of the using the key value, what will happen is, it is not the same that all are fitting into different locations. There are possibilities where the keys are mapped into the same location also, based upon the key value. So why it is mapped into the same location is, I'll tell you how it is actually done. So when it is mapped, actually what happens, when many multiple elements are mapped into the same location, what happens is, there will be some sort of collision when you are searching, or when you want to retrieve that particular element. What will happen is, already there will be some more elements. This also will be added up, so that there will be some sort of collision. So to avoid this collision, there are few techniques also which we have to follow. Okay, so collision means mapping two or more keys to the same position in the hash table. This is called as collision. So what are the avoidance techniques will be? Separate chaining, open addressing. So separate chaining is called as open hashing. Open hashing, why it is called as open hashing is, in the chaining techniques, when you take it into a table, the particular elements are not mapped into the table. please mute your microphone, ma. So open addressing will be, open hashing will be when you are mapping the particular elements into the table. Instead of fitting directly into the table, it uses a pointer where the pointer will be used for accessing the elements. So the pointer only will be, address will be stored, and the pointer will help you. See, in linked list, what you will do, the pointer only will tell you where is the next particular element is. So here also, what will happen is when the table is like this, instead of fitting inside this, you will have a link like linked list. So outside only actually your key value will be there. Key value means your element will be there. So what happens, that is what it is called as open hashing. It is outside the table. Link will be there, but the values will be fitted outside the table. So that is called as open hashing. Open addressing only, it is called as closed hashing. So if they ask you in the other way also, you should know. If they ask you to explain open hashing, you should know that it is not open addressing, it is separate chaining. If it is closed hashing, it is open addressing. Okay, why it is called as closed hashing is all the key values will be fixed directly here itself, not like not pointing outside. That is called as closed, somewhere else closed inside the table. So that is only open addressing. So all these techniques comes under open addressing: linear probing, quadratic probing, double hashing. Then rehashing, extendable hashing is other different techniques. So normally I can tell you in your collision avoidance techniques, there are four techniques: separate chaining, open addressing, rehashing, extendable hashing. In open addressing, you have the three methods, these three methods. So we will see all the methods one by one. So separate chaining will be each table entry stores a list of items and a pointer field, as I told you. A pointer field is added to each record. When overflow occurs, this pointer is set to print the overflow blocks. That is, even if it is in the same location, it gets added up to the pointer itself. In the pointer, it will be in the next locations. In the same index table, by means of pointers, it will have connections to one another. That is only called as separate chaining. So advantage will be you can insert as many number of elements because there is a chaining process. But actually the disadvantage will be pointers required, which occupies more space. And when you search an element also, even though you find the index value, index value is, this is the index value. If it is a single element, it is easier to find. But if there are multiple elements chained together, then if you are going to search the last element, then it will find the index value, then it will search here, then this element, then this element. Likewise, it goes on. So it takes more time for searching. So I'll show you with an example. 1 minute, let me see whether this works fine. So this comes one by one. The table size is 10 and hash function is, this is what you have to remember. Table size, they will give it, and hash function will be k mod table size. This is the formula which you are going to apply. H of k will be k mod table size. K is your key element, that is the keys which you are inserting, and the table size is what they give. If they normally table size in the problem itself they will give it, or else you can fix a size. If they are not giving it, you can take any size, or mostly all the problems they give the table size. Say k mod table size. So 83, 14, 29, 10, 74, 36, 96, 67. So here I have the same number only you have to take, but I'll tell this as per this. You need not arrange it anywhere. As per the order, you have to take it. So you have to take the elements as per the order. So this now 14 is the first element which they have given for us to insert. So what we have to do, what is the formula I told you? Can anyone tell me the formula?
K mod table size.
Yeah, k mod table size. So 14 mod 10. H of k is equal to, here I have given 14 mod 10. So the value will be 4. So where will be 14 inserted? In the Index value 4. Okay, it is not in the fourth location. It will go to the index value. Index value 4. So in 4, 14 will be placed. So here, as I told you, this is separate chaining. That is, your linked pointers will be used here. So it will be stored as a linked list only. So 14 is here. Okay, 14 is here. Next, 67. So 67 mod 10 will be 7. So 7, where it will be in the which location?
Position 7, ma'am.
7 position. That's index value 7 itself. Now you don't count as
Yeah,
per
index
this
value, like
location.
beside
Index,
7.
7. So since table size is 10, I have taken from 0 to 9. Okay, table size is 10, so 0 to 9. So 67 is now inserted here. So 83 answer will be
3.
3. So 3 here you have inserted. 36 will be again 36 is also 3. You see here 36 is also showing 3. So where it will be inserted? Already 383 is there. 33 36 where it 36 mod 10 will be 6, no? The answer here 6. Answer should be 6, okay. So 36 will be in 6. I have located here. Here there should be a small change. 6 should be there. Okay, so now again 10 mod 10, 0. 29, 9th location. 74 will be in the 4th location. 74 in 4. So where it will be inserted?
In 4 after 14.
After 14, yes, because it is linked list. It follows the linked list procedure or chaining procedure. So 14 will hold the address of the next one. So 74 is done over here. Okay, now 96 also it should be 6. So here by mistake these two places I have done it, but anyway connection I have done it properly only. So 96 will be in here in 6th location after 36. Okay, so this is how. So similarly, if there is some other element, it keeps on inserting. Maybe if I am receiving another one like 104 or again 64, so again 4, so it will come here. So what happens is you can insert multiple number of elements over here, since there are it is a chaining process. But when I want to retrieve or search, what happens is after finding the location, I have to go and find whether 36 is the element to be searched. Then here, if the linking is many number of having so many elements, then it will be searching will be very searching takes a lot of time here. So that is why separate chaining was overcome. This disadvantage in separate chaining was overcome by the, so other things you have to ground it to null. When it is end, you can ground it to null. So if they give you a list of elements, set of elements, table size, and the key elements, table size, then you have to hash the particular elements into like this. Your problem solving will be like this. You have to solve the problem. You have to explain in words also, provided you have to draw this table and you have to link the elements based upon what technique they have asked. So now this disadvantage is only overcome by means of open addressing. So open addressing will be is also called as closed hashing. So here alternate way to resolve collision. Collision is avoided. Here also collision is avoided, but using by using chaining technique, separate chaining technique or linked list. But it takes that, but disadvantage in linked list is overcome by these 3 techniques. So this also avoids collision only: linear probing, quadratic probing, and double hashing. So linear probing, the formula you should note. See the formula for linear probing. It is h of, normally your formula is k mod table size. So h of k, that hash function is given by h of k plus initially when you are going for the first initial checking, you can give h of k mod table size. If the table, if the index value is already filled, then only you will be going to h of k plus 1. Probing means moving to the next step, second time, third time, fourth time, fifth time, likewise. So when you are calculating initially, you can use h of k mod table size only, default formula only, hash function formula only. But when you calculate it for the first time and you find that already the particular index value is filled by the any one of the key, then if you are going for the next step, you have to give +1. Why we are giving h of k +1? What answer you got here, that answer +1 mod the table size. It's not the key element +1, answer +1. Okay, that I'll show you an example. Mod table size. Again, this also is filled now. This element is also, so this is also, okay, so this is also filled, means then you go for the next step. Okay, now when you are going for the next step, you have to use here h of k +2. Maybe if you have got 5th position here, initially 5 + 1, 6th position you have to fill. That is the meaning. Now 6th is also already filled, means then don't go with 6 + 2, h of k initial value +2. So 7th position. This is also filled, means you will be going for the 8th position. Likewise, you will be moving. So in general, you have to remind this formula. H of k, maybe how many steps you are moving. I means ith step you have to fill h of k +1. Okay. So time is not required for allocating new cells. There are no pointers also. But what happens is it will form clusters for storing and retrieving the data, which degrades the performance. Clusters in the sense when you are probing the particular formula, each time it goes and checks into that particular hash table. So at that time, in case sometimes by in rare cases, what happens, instead of moving to the next prob, this particular table will be value will be filled into that. This happens in rare case. So some sort of clusters will be formed each time when there is a checking by. So to retrieve that, we will be going for the next technique. So I'll show you with example now. Wait. So 14, 18, this I have taken, and same table size is 10. So first 14 mod 10 will be 4. So 4 will be 4 is placed, 4th position, 14 is placed. Again 83 mod mod 10 3. So 3 is vacant only. So 3 I will place 83. Now next one 36 mod 10. So 6. So 6 will be placed in the 36 will be placed in the 6th position. Now what is the next one? Can anyone tell me?
10 will be placed in 0.
Okay, next 29.
29 and 9.
9. Okay, next
74.
okay, 74 in which place?
5.
Yeah, 5. So why it is 5? Can you explain?
4 is occupied.
Yeah, 4 is occupied. So you will be going for the next step. What is your procedure to move to the next step? H of k plus
+1 mod 10.
1 mod 10. Okay, good. So what happens is in prob 0, first calculation you have to do. You have to show this in the calculation. H of k 74 mod 10. 4 is already occupied. 4 is already occupied by 14. So in prob 1, as per our formula, h of k plus 1, because it is the first step, plus I. I means first step, I, 1. So 4, this not 74 plus 1, don't change the element. It is the value, index value plus 1. So already what index value, which original index value, plus 1. So 4 plus 1 is 5. 5 mod 10. Now next 96. So 36, 74 is placed in 5th
7.
position. 96 in 7th
7.
position. Good. So 96 and 6th already occupied. So it will go for 6 plus 1, 7. So 7th position. Now again last one
8.
is 66. Yeah, 8 is. Good. So 66, 6 is already occupied. So in prob 1 I will be calculating 6 plus 1. So manually also you can do here by looking into the table, but always you have to do calculations for marks. So if it is MCQs, you can jump into the direct way of whether next one is occupied. Yes means you can go for the next. For linear probing, it will be easy. It will go to the next, and it will check and go. So here, but actual by procedure, 6 is already occupied. Then prob 1, 6 plus 1, 7. That is also already occupied. Then prob 2. So prob 2 means this 6th original position plus 2. So it is 8. So it will go and get placed in the 8th location. Okay, this is what you are linear probing. If you understand linear probing, quadratic and the next probing will be very easy. Not rehashing, linear, double hashing. Rehashing is different, double hashing is different. So next is quadratic probing. So in quadratic probings, look into the formula. H of k is equal to, general formula I'm telling, h of k plus I square. Your linear was I, this is I square. So how we have got this formula is, initially h of k mod table size only. The same formula only you have to apply first, initial formula. When this is occupied only, I will be going for the first step, I will be going with 1 only. 1 mod table size. So if this is 5, I'll be going with 5 plus 1, that is 6. Okay, but the 6 is also occupied, means in prop 2 I'll be going with 4, that is 2 square. It is not 2, 2 square. So what will happen is actually, which position will I take here? Which position will I take here? 5 plus
4, 9.
9. Yes. So 5 plus 4 will be the next. That is 9th position only I'll take. If 9th is also occupied, then I will go with the next position. So I'll show you. So what happens? 3 square. So similarly, it will go till 9 square. I square. So your formula is based upon the prob, the square gets increases. Okay. So now we'll go with the example. 0, 14. So 4, so it is placing in the 4th position, and 83 mod 10 is 3 in the 3rd position. 36 mod 10 6th position. 10 mod 10 in the 0th position. Then 29 mod 10 in the 9th position. Now what will be my answer? What will be my answer next one? 96 in 6th position already occupied.
96
So
in
what will
7th
be my answer? What?
96 in 7th position.
No. 7th. Yes, for 7th is free. No, okay. 7th position. If not, 7 is occupied means
10th position.
where is the 10th position? Calculate and see. 9.
5. 5.
Yeah, if 7 is occupied, 1, 2, 3. No, square, no. Actually, 6 will be if, for example, 6th is occupied, 7th is occupied. 6 plus 4. 6 plus 4. So 10 means actually 6 plus 4. So 10 mod 10. Listen very carefully. 6 plus 4 is 10 mod 10, right? Wait.
0 is occupied, ma'am.
Yeah, 0 is occupied. So it will go to 6 plus 3 square, right? 2 square,
it will
4
go to
is
5.
occupied. 5, okay, good. So this is the way how you have to calculate. So now I'll show you it. So here in 96, it is okay. 96 mod 10, 6 is already occupied, so plus 1. 66 now. So 66, when it goes for 66, already this 96 is in the 7th position. So this is occupied, so which position it has to go? So see here. 66 mod 10, 6 is already occupied. Then in prob 1, it will go with plus 1 only. So 6 plus 1. So 7 is already occupied. In prop 2, it will go with 2 square. I told you it is plus I square. So 2 square, it will go with 6 plus this value plus 4. So 10. So 10 mod 10 is 0, already occupied. So it will go with prop 3. Prop 3 means plus 9, 3 square. So 6 plus 9. 6 plus 9 means 15. 15 mod 10, the answer is 5. So it will get placed in the 5th position. Clear? Clear, students?
Ma'am, so this is like a
100%, ma'am.
circular
Yeah.
linked list sort of, I mean, circular thing. Like.
Yeah, it goes on like this. But there is
Ma'am,
some sort of index elements where it directly get placed into the, based upon the hash function.
ma'am, for example, if in linear, the same thing, in the ninth position, there was 29.
Yeah,
And
it
there
will
was
go
something,
to 0.
there was, okay, so if there's a 99 after
0.
that, it'll go into 0.
0. If 0 is occupied means it will go to 1.
Okay.
By calculation itself, you will get the same answer only. Okay?
Yes.
Okay. So now double
Ma'am,
hashing.
why do we have to do this uselessly in quadratic formula? In linear one, it was simple and so on only, no?
In quadratic, why we are giving is all the time linear. Sometimes if continuous linear function, if there are continuous number of elements occupied, what will happen? Linear goes by one only. Okay, so this
Ma'am, so
quadratic
here also
will
you're
search.
depending on luck.
No, only
So,
only depending on the log, but it searches the entire table. See, for example, in linear probing, if continuously, continuously these numbers are occupied. Okay, so but what happens in linear probing? Each time it checks with only one increased value. So in this case, what happens is there is a chance of mistakenly getting placed somewhere else in the middle. So sometimes if the algorithm fails in linear probing, if see here the table size is 9, that's what it is very easy for you. 10. If it is a very big table size, in linear probing, each time if it is moved one by one, it is a very long process to finish and place the particular value. But in quadratic probing, what it will do is, it can make a jump. The entire table can be searched in based upon the steps, it makes a longer jump, right? So in that case, there is a chance of, because normally when you make a table itself, what happens? The elements which they place, normally they place it in a linear probing, it will be in a linear manner. So suddenly an element is going to be getting inserted in one place. It will start from the beginning only. Each and everything it keeps on searching. But this is like something which is more advantage than quadratic. The function is doubled. When it is doubled, maybe somewhere else, if there is space also, it can goes and occupy in the last case of your table even. Instead of going and getting placed in the middle of the elements. Even if there is no places there, it has to check each one by one based upon the function. Then only it is going to the next. See, if this hashing is mainly used for a larger table. Smaller table, it is fine, we can find it easily. For a larger table, normally if the large spaces are left out at the last, assume that you have partially filled, for the first half is filled up and the last half remains remains empty. In that cases, more than your linear probing, your quadratic probing will be finishing it fastly by doubling the numbers. Understood? So that is what there will be, see that not much difference, but some sort of insertion can be easier compared to your linear probing. So this is also one of the way where you can occupy. In linear probing, when you check, you have to see maybe this 7 even, in maybe for example, 66 is there. In linear probing, how many iterations it will take or how many steps it will take to get placed. If this is also filled means, it will take multiple steps to come over and get placed in one, right? If this is continuously filled. If the position is 6, it has found 6, but this is filled, this is filled, this is filled, this is filled, means each time how many steps are getting prob 0, Prob 1, 2, 3, 4, 5, maybe in the sixth prob only it will place in 1. Clear? But in your 66, in your third prob itself, it is finding a right place and it is getting filled in 5. So see the steps, how it is actually. Okay, so this is the advantage in your linear and quadratic. Okay, in quadratic, the steps will be, probing will be reduced. But in linear probing, if the numbers are continuously occupied, then it has to go and find each one separately, one by one only. But this find randomly when we do I squared, this 3 I square, that is 2 square, 3 square, means even though it can directly find it even in the second step or in the third step itself. Clear? But more than this, again, this will be more easy. This will get placed. So see, all the algorithms, they'll be making little bit modifications only to make it easier. So linear is the first one which they have found. So if they have not mentioned any type of probing, means you have to follow linear only actually. Default actually. If they have mentioned apply quadratic and double hashing only, you'll be going for this technique. Compared to quadratic probing, double hashing is again a very faster technique. It will be very fast than your quadratic probing. Why? Because is 2 hashing functions are used. Why 2 hashing functions is, this will be maybe some sort of disadvantage may be followed here. Mainly timing only. Than linear probing, quadratic is faster. Than quadratic, double will be faster. Why it is double hashing is, see here, since there are 2 hash functions, 2 hash functions is h of k is one function, g of k is one function. So h of k is normal. What you actually do, what that is that? This function, and g of k is this function. G of k is I into hash 2 of x. So g of k, that hash 2. What is this hash 2? Hash 2 only is the second hash function. This you have to keep it in mind. Hash 2 means r minus x mod r. This is a different hash function. Why r minus x mod r? You are going to use this hash function to reduce the probing or to reduce the steps, I can tell you. So more than quadratic probing, these steps will be reduced in a very fast manner. Instead of going for multiple probes till I, it might get your answer, your index value can be found out easily by the second step or even in the third step. See, if linear probing is finding it in the 8th step, means quadratic probing can find it in the 4th step itself. In prob 4 itself, it will find the place. But double hashing will find the place in the prob 2 itself. That is the meaning. So if linear probing, your answer is getting, you are finding the index value in the 8th prob. Assume that you are probing it, you are finding it in the 8th step or 8th prob. Your quadratic will find in the 4th prob itself, but will find the index value in the 4th. Double hashing will find in the 2nd prob itself. That is what is the advantage. So how it is finding in the 2nd prob is 2 functions has to be followed, h of k and g of k. So initially the same sequence only, h of k you will be follow. If it is in the first step, fine, you can leave it out. Otherwise, h of k plus 1 plus not it is plus 1, h of k plus 1 into g of k. What is that 1 into? 1 into is based upon, if it is the first step, 1 into. Second step, 2 into. Third step, 3 into. So ith step means it should be I into. G of k you have to calculate separately. G of k is r minus x mod r. X is the key value. And what is r is, listen very, very carefully, this r is very important. Students make mistake in this r only. Others, they'll go fine. R is the table size. Based upon the table size, it should be smaller than, if the table size is 10, you have to take a smaller table size, but that should be a prime. You have to check it for prime also. So what is the smaller, immediate smaller value than 10, which is a prime number? Can you tell me?
7.
7. Yes. So 7 should be, so when you calculate hash to function, this R will take the value of 7 minus X will be the key value, what is already there, mod 7. For this function alone, you have to find like that, based upon the table value. If the table is size is 15, what is the prime number? What is R? R. 15 means what is R?
13.
13. Okay, so now coming to the next one. Table size I have taken as 7. So 0 to 6. So what should be my R?
5.
5. Good. So now I will calculate. First 76 mod 10. So it is 6. I will place it in 6. Then 93 mod 10 I am telling. Mod 7. Okay, so it is 6. Now 93 mod 7. It is 2. You can calculate. So it is 2. I am placing it in 2. 40 mod 7. It is 5. So I have placed it here. And 47 mod 7. So now see here. 47 mod 7 is 5 already occupied. 5 is already occupied. So I will go for the first prob. How I am calculating the first prob is prob 1. H of k. Calculate first h of k. H of k is already not done. 5. So 5 plus this value. I have to find this value. I have to find this value. 1 into g of k. So 1 into, let it be, g of k I have to find. 1, why I am keeping it as 1? It is prob 1. So how I have to find the g of k is r minus x mod r. R is, I told you, smallest size, table size than your current table size, smaller prime number. So it is, your table size is 7. So next smallest is 5. So 5 minus, the value here is 47, x value, that is the key value, 47, mod 5. So my answer is 3. So 1 into 3 is 3. So 5 plus 3 mod 7. So 1. I'm putting it in the first place. Okay. So it is getting occupied in the 47 itself. So instead of 5, instead of linearly checking there, so it is getting occupied in the fourth position. In the first position. Now if I go for 10, 10 mod 7 is 3. It is place is vacant. Now 55, again 55 mod 7. 55 mod 7 will be 6. 6 is already occupied. So again I will calculate. So the answer is 4. So 4 is vacant. Suppose if the answer is not, 4 is also filled, then go for h of k plus 2 into g of k. Okay, 2 into g of k. G of k already we have found. So only answer you have to get is 6 plus 2 into 5. So 10 it will be. Something around that you will be getting. Okay. So g of k only one time you will be finding it. Always it remains the same only. Only the thing is this will keep on changing. 2 into g of k, 3 into g of k, based upon it will change. Clear now? So this is what called as your double hashing. So double hashing, next one is actually rehashing. Don't confuse double hashing with rehashing. By the name, see what is the time?
10 minutes left.
ma'am.
Okay, 10 minutes left. Okay, I'll finish with rehashing. So rehashing is very easy. That is when your table is half full itself, you have to double the table size. That's all. You have to double it. Rehash as soon as the table is half full, or if you are not able to insert. So twice you have to. How you have to rehash is you have to twice the table size, and again you have to fit all the values once again based upon the new table size. When you are fitting, you have to follow, in rehashing you have to follow linear probing function only. Okay, advantages, you need not worry about the table size. It is simple to implement also. So how it is simple to implement is rehashing only doubling the table size. So for that, don't mistake it with double hashing. Double hashing has a separate 2 hash functions. Rehashing is doubling the table size. When you double the table size also, maybe if the table size is 10, and if you double the table size 10 into 2, 20, you should not take 20, you should take the nearest prime to it. Okay, next prime to it. Okay, so now I'll tell you, wait. Here you should not reduce it, you have to increase the next prime. So if it is 20, what is the next prime to 20? Bigger number. Take the next one, bigger one.
Ma'am, you told when this is 20. What is 20?
No. If the table size is 10,
Okay.
okay? If the table size is 10, and most of your table is full, maybe around 8 elements, half full even itself you have to rehash. So 6 elements, 6 places are occupied. You have only 4 places left. At that time itself, you can do the rehashing. Okay, you need not wait for to get the entire table full, or else you are not able to insert the particular element. You have no space to insert the particular element. Then also you can rehash it. How you have to rehash is double the table size. So if your table size is 10, what you have to do is 10 into 2. Doubling is 10 into 2, right? So 10 into 2 is 20. Your table size, new table size is 20. But you should not take as it is. By rehashing rule, what is the rehashing rule is double the table size and follow the next prime of the table. So if the 20 is the answer which you are getting, what is the next prime
23.
of 23? So your table size will be 23. So how you will mark the table? 0 to
22.
22.
Yes. So see, if your table size is not 10, you have to double it. So 10 into 2. 10 into 2 will be 20. But 20 cannot be the table size. Should be the next
Ma'am,
prime.
why not 20, ma'am?
For rehashing rule itself is that only. Your algorithm itself will follow that technique only. Okay, 20, they are taking only the prime numbers to be followed in the table size when you are doing a double hashing. That is, when you are rehashing it, you have to take only the instead of taking 20, you have to follow the next prime techniques. Okay, certain things it's fixed in rehashing. It will be maybe due to some disadvantage, it might be, because sometimes instead of taking directly 20 and applying the concept of 23, maybe the next prime would occupy more number of elements instead of having 20. So by that rule they would have taken, like in your double hashing, what you do. No, wait a minute. In your double hashing, what you did actually, how they fix the R as the smallest prime. So it is better if you take R as the smallest prime. By experiment only they would have fixed these values, right? They fixed these criterias. So the person who have designed this, by experiment only they would have fixed. So instead of taking a smaller number, maybe 6, or maybe if the table size is 7, and instead they take 6 and do the calculations. More than that, if it is a prime number, they would have experienced the good insertion into the table. Maybe most of the space would have been occupied, or the answers which they fit into would have been easier to fit into. So they decided to have this R itself as a smaller prime than the table size. So same thing in rehashing also, instead of directly taking it as 20 and applying all the values once again into the new value, they would have faced some difficulty. Maybe we are trying with very small numbers, but by experiment they would have taken very large table size and they would have sorted it out. So when the particular founder have done this, they would have experienced some sort of disadvantage while insertion. So the better thing is, if it is going with the next prime, they should fix some criteria, right, for the particular, because everywhere the same conditions has to be followed, right? So when the particular condition is being followed, See, like your maybe if you're instead of taking 20 or 21 even, sometimes they would have faced the difficulty. So otherwise, if they have taken 21, they would have given double table size plus 1 itself is enough. But instead of going to that, if you take the next prime, by experiment they would have experienced a very good insertion, or the timing would have been saved, or it should have been the particular key value would have been very easier to find. So some sort of advantage will be there when they have fixed this criteria. So when you are also doing double hashing, go with the follow the criteria, then only your answer will be correct also. So here you see my table size is 7. So when I start to insert 6, now 15 mod 7, 1, then 23, then 24, then linear probing, right? So when it is already occupied, I'll go with the next. Now see here, when the table is half full, only 3 spaces are there. What I will do, when 13 is to be inserted, only 3, even though there is space, and the table is half full itself, by rule, what they are telling is double the table size. So new table size will be 2 into old table size. So 14. Choose the next prime. 14, next prime is 17. 15, 16, so 17. So your new table size will be like this. 0 to 16 will be a new table size. 17 is a table size, 0 to 16. So when 17 is your table size, you have to again not only include, you have to again start from the first. So 6 mod 17. Okay, 6 mod 17, your answer will be, it will place in the 6th position. Then 15 mod 17. The next, then 23 mod 17. All the numbers you have to start to insert from the first. You should not think that only 13 we have to find the answer. All the numbers you have to rehash it into the new table.